Okay, so we're going to start off with the 2-inch standard lens. This is what, 1, 2, 3, 4, 5 ply. It's about 5/16 of an inch, which is about 7 millimeters. I'm going to place it just here, and we're going to do the same thing. We're going to cut out squares and find the best cut or the best speed and power to cut this out. So I'll just place this in between the IR beams here, and we're going to lower it first. Then I'm going to press menu. Autofocus is highlighted here, so I'm just going to press enter. And the job is done. I already have a 2-inch square logged into this, but of course the speed and the power is set for 1/8 inch MDF. So we're going to alter the speed and the power rating directly in the reader controller. So let's just bring the head over and bring it somewhere. Actually, we'll do it in the middle there. It might be easier to, like that. And then what we're going to do is press origin. So now that's logged into the controller, that is the start of the program there. So now we're going to alter the speed and power of the program that's in here. So let's have a look. File, enter, and here it is. Okay, what I realized the camera wasn't on the control panel here. So what I actually did was I just went file, which I loaded this file in the other day, and it's highlighted, and you just press enter. So then here, that layer of that file with the speed and power rating actually comes in. Now this was set for 1/8 inch or 3 millimeters of MDF. So we need to raise the power, which is the first figure, and also so we need to raise the power, which is 25%, and also reduce 20 millimeters a second to start with anyway. So the way we do that is we go enter, enter. Now that brings up this menu. So one click of the menu will take you down to, first of all, the speed. So 20 millimeters a second is a little bit too much, so press an arrow. We're going to come across this way. It'll highlight a cursor. I think we're going to start off with probably 10, so we just want to alter that down to 10. Then menu 25%. I think probably 35. You know, this laser is very new. It's actually surprised me already, but I'm going to say 35 because I'm really not sure. I don't know what the 0.1 is doing there, so we'll probably get rid of that. So we're going to go 30, so that's up 1, 35. And we're going to come across here, and we're going to go down 1 to make that 35. So we'll alter the rest to 35 too. I think that max power 1 and 2, I think maybe that's, I'm not really sure, I'll have to look at the manual, but I think that's running. I think this is the initial fire through, and this is running. So we're going to make them all 35 anyway. So we're going to come here, go 30, which is up one. Then next one, there, we get 30 up one. And here, there, 30 up one, and enter. Successful. Setup success. And press enter again, brings you out of that. So now we're at 10 millimeters per second and 35%. Like I say, it's a completely new laser to me. I'm not sure what it's going to do, whether it will punch through that or whether it's, you know, it'll not. We'll soon find out anyway. Okay, so I'm videoing this through a layer of glass. Obviously the door's shut, so hopefully it's going to come out all right. So we're going to turn the pure air unit on, the extraction unit. So we've got that going at just over 2000 RPM, which is quite a nice flow through. And okay, let's just do a frame test. Okay, so let's press start. Well, I can see the smoke coming out underneath. There's some coming out of the top too. Yeah, I think that's probably not enough power. So you can hear the high pressure airflow now going as well. That should cut out in a second. There you go, that cut out. And also the cooler just cut out. Oh. That, I don't know whether you can see that. Hang on, I'll just get the camera focused in a little bit better. Well, I don't mind telling you that that is not quite perfect, but it's not far off. First damn cut. I mean, alright, I've been using lasers for years, and I just took a potluck. That's not bad. That's not bad. You can see better now. I've come across with it rather than take the camera and try and show you there. You can see the grain pattern, you can see the light and dark shades of the ply. It's not burnt at all, but it's not. We can do a little better than that, I think. But that is pretty damn good. There is one thing I noticed that you know, everybody does have the problem. It's not really a problem, and that is on the back. If it isn't overexposed, can you see that? You see the little tiny reflections there, all the way around of the honeycomb. That's the honeycomb. The laser, when it cuts through, it reflects slightly off the mild steel honeycomb and just hits back up at the base. Now I'm going to show you how to overcome that very quickly. It's a very easy thing actually to do. You're not worried about it on the waste material. It happens on that as well. but we're going to get over that problem now. That's a really good cut, first off. But like I say, I've been using lasers for years, and I just took sort of I suppose, an educated guess at it. But that isn't efficient. 10 millimeters a second is not efficient enough. So we're going to take the efficiency level up, and we're going to see if we can make that a little better. Okay, the idea is to cut through cleanly so it drops out, virtually drops out, and with the least amount of cleanup afterwards. It's all about efficiency, and you don't want it burning black. That's a pretty reasonable damn cut. Okay, so let's we're going to do a number of things now. I'll show you the method I use to stop the reflections on the back, and also we're going to speed this process up by altering the power of the laser and the speed, because that's what I think it needs: more power and more speed. Okay, we're going to overcome a couple of problems here. Now, I'm sure you can see on camera the squares of residue that's left in the honeycomb. Now, that is condensate. What a laser does, when it pierces through the material, it evaporates the material to a gas. And some of that evaporated material condenses on the honeycomb and leaves like a tarry substance behind, nasty, smelly, horrible, tarry stuff. To minimize that, and also minimize the reflections on the back of your material, of your part that you want to have as pristine as you can, coming straight out of the laser, I use these. They're magnets. They're actually from the dollar store, and they're for coat hangers inside a metal cloakroom cabinet affair. Okay, so you just stick it on the wall, and it normally has a metal hook coming out here, and they are perfect for lasers. So what I'm going to do is just put one here, and of course they're magnets, so they won't move. I also use them to pin material down, but Thunder Laser actually supplies some rare earth magnets for that. So just roughly, and of course they'll attach to this because this is mild steel. One there and one there. Might have to move them a bit. Get right at the corner, like so. And if the laser when the laser passes through the material, if they pass over this, it will give a very small reflection in that area only. So you sort of position them away from the cut if you can, but they won't do any harm. It's just roughly like that. Of course, there's not really any side forces on the material, but if you're using lighter material and you was doing an etching or engraving, the motion of this going back and forth, and it may move the material, so you may require other magnets or some other mechanism to hold it side to side. Okay, so I'm now, one job I have to do that I nearly forgot then. So the job that I need to do now is actually put these up here, because I need to refocus. Now I've altered the height of this material in relation to the laser, the nozzle. I've now got to drop this table down and refocus it. Okay. Okay, so having refocused it, I've got to put a new datum area now on here. So okay, and I'm pressing origin. Okay, without changing anything else, because I want to give you a true reading, so the power and the feed is exactly the same. I'm just going to do the same cut, just with this lifted off the table. So I don't know whether you just heard, but that was my pretty quiet compressor just started up then over the back there. Just wait for the blowing mechanism to stop. There you go. Okay, so there's the top of both of them. So the one I've marked here was the first one we did. And there's the back. So you can see the reflection marks have just disappeared. So that's one problem solved. Okay, and you know the cut is still the same. Okay, still the same, but the reflection marks are gone. So that's one easy solution to get rid of those pesky little reflection marks off the back. Because some materials or some jobs that you do, you require the back to be clean, you know, and you can't get much cleaner than that. Okay, so that solves that problem. Next thing we need to do now is speed the process up, and to do that we're going to need more power and more speed. Okay, so what we need to do is press enter to highlight the program, which is in this window. There's also a representation of what the work is. If we was doing lettering or something like that, sign work, obviously a representation of it would come here, but as we've just got a simple square, that's where it is there in red. So we'll press enter. So now we're going to start altering these figures. So quickly, so at the moment I'm going to leave that at 10 because I want to show you the difference in color and quality of cut. So I'm going to leave it at 10. I'm just going to raise the power. So we're going to go significantly up here. So we're going to say, oh, let's be daring. Let's say 55. Because what we're after is efficiency here, and I'm going to show you how to get there. So I've set them all at 55. Press enter. Setup success. Okay, so let's see what we can do here. Okay, so we need to give it a new origin, so we're going to move it over slightly. That'll do. Press origin, frame, and let's start. As you can see, it dropped out, and it's actually a good clean cut. That's what the difference of this air blowing system too. That's a big help to make it cut cleanly. Well, I think we can do it a lot faster. So I'm gonna continue, and I'm gonna go up in steps of, say, 1 or 2 millimeters, leaving the power the same as it is, and I'll get back to you when I've done a few. Okay, so this is the result of the testing that I have found. Cutting this, what is it? I think it's 5/16 of an inch, which is about 7 millimeters. So we started off with 10 millimeters a second at 55% power, and I raised it up by 1 millimeter in speed for each cut. Now, by itself like that, it doesn't tell you very much. So what I'm going to do is stand them all up on end and put them in one block. Now, I'm not sure whether the camera's actually picking that up, but I can pick it up with my eye. It starts off darker at this end, and as the speed increases, the material cut edge gets lighter and lighter and lighter, until up here, this is 19 millimeters per second at 55% output, 55% power. Now, I would say that, see, 19, 18, 17, I think about 17, 18, 17, that would be probably, my guess, would be the perfect setting. Okay, it will cut it at 19, but it did, if you notice, I don't know, we can see down here, it just had some fibres hanging onto it and I had to push it out. It's not ideal. It's nice to have it fall out without burning the edge. So this, in engineering terms, is a telltale. It's a picture that tells you exactly what is happening with the cut. So this is how you achieve the best cutting results. And you will also see, having the material just slightly raised, about 10 millimeters, up off the bed, the honeycomb, you can still detect there is a very, very small amount of residue attached to the honeycomb, but it's vastly reduced and there is no reflection. So that's a number of, should we say, niggling little problems solved, just with you know, sort of simple mechanisms. So I hope that's been a little bit of a help to you, to start you off getting the right cut with your Thunder Laser. There is one thing I will mention. This was at 17 millimeters per second, 55% power, even though it's a beautiful cut, and that's the one I would recommend with the 2-inch lens. If there is a small void, okay, see that small void in the actual laminations? Sometimes, and nearly always actually, the laser will not penetrate the very, very last bit. You see there? That white mark? That's because when the laser comes out into a void, it sort of, I suppose, diffuses. Only for a split second, but it makes that little hiccup in the cut. Okay? You know, this wasn't, I suppose, this isn't furniture grade plywood. This is just ordinary DIY plywood. So, you know, the higher grade plywood, you know, doesn't really have those types of voids. But, you know, it's not really a problem. All I'm saying is if you do get hung up, you know, if you're doing some cutting and all of a sudden one piece doesn't drop out, or, you know, you get a couple of sort of miscuts, that's generally the reason, because there's a small void in the material. Okay? So I think that'll do for this little video. Please like and subscribe, and if you like what I'm doing, you might consider becoming a patron to the channel. That's always a help. And I think in the next video we're going to up the ante quite a bit, and we will start cutting some 1/2 inch and might even go to 3/4, but not with the 2-inch lens. It will cut 1/2 inch ply, but you know, it's fairly slow and you can't really get what I would call a good cut. So what we're going to do is we're going to put the 4-inch lens in, and we're going to do some test cuts with that. Okay, so thank you for joining me, and it's bye for now.